What's up everyone, Lukonde Mwila here, back with another video, and we're talking containers, K8s, and Datree. Getting started with containers is relatively straightforward. If you have an environment like your personal laptop with a container runtime such as Docker or Containerd, the Docker CLI, and a Dockerfile for your application, then you can have a container up and running in no time. In scenarios where you have a large number of containers that you need to orchestrate with Kubernetes, the simplicity around containers often results in people overlooking the best practices, especially the ones that pertain to security. And I suppose in the middle of all the Kubernetes cluster configurations, it's pretty easy for these best practices to become a bit of an afterthought. But securing your containers is a foundational part of your cloud-native security strategy, especially if you intend to do it at scale. And this can start with your Dockerfile and carry over into your Kubernetes resources in the container spec configurations. The best way to accomplish such security measures for your containers is to use a tool that has an updated exhaustive list that you can use to vet your workloads. And that's where Datree helps. So in this video, I'm going to walk you through some battle-tested rules and how Datree can help you secure your container workloads by using the container-focused policy. Let's take a look at this in action.
So we'll start off by considering the user capabilities of our containers. As great as containers are, you want to be able to limit what they can actually do on your hosts. And there are different measures you can take to prevent potential misuse through containers with elevated permissions. And a quick win is to disable root user capabilities by defining a user for your container with unprivileged access. So if you take a look at this particular Dockerfile, you'll see that the non-privileged user node is given the relevant permissions to execute the program that I intend to run, as opposed to using the root user by default. And in addition, I can configure the security context inside of my deployment manifest. But before we start getting into the best practices for your deployment resource, I want to talk a bit about going with the bare minimum approach. And the reason I want to do that is because I think there are a lot of people that don't implement best practices, not because they don't care, but more so just because, as I mentioned earlier, when you're involved in so many other configurations, it's easy for these things to fly under the hood, and it can easily become a bit of an afterthought, or you overlook a number of things, or it could also just be a case of not knowing what those best practices are. So you might simply copy paste something from Stack Overflow or from Docs or an article that you saw. So if you take a look at this deployment manifest, it probably contains the minimum properties that you would expect to have in a deployment, but there are a number of optimal specifications that are actually missing, and not just for better security, but also for resource management. And some of you might be using a deployment like this in production, and your application will still work. But the question is this the best way to do it? So I'm going to deploy this manifest as it is, and we'll see if we run into any issues. And what I want you to pay close attention to is the liveness probe, which I've created over here. And by all indications, it looks totally fine, apart from VS Code Editor telling me that I need to improve something about this particular manifest file. So let me go ahead and create this inside of my Kubernetes cluster. As you can see, we got 3 replicas that are coming up, and from what we can see, they are all running, which is great. So that means that if someone attempts to access this application, then it should work as expected. But that's just taking things at face value. Let's dive a little deeper and see exactly what's going on. Remember, I added a liveness probe, and that particular liveness probe is going to be sending requests, HTTP requests, to this particular endpoint. And as I said, sometimes we just copy and paste a particular manifest resource that we see online because we think, okay, that's good enough, so I'm only going to change the relevant properties like the image and the container name and maybe the number of replicas. So let's take a look at this again, and you'll notice already that the restart count is slowly starting to increase. And compared to the other containers, which have been running for quite some time, they're still on a count of 0, but this one is slowly increasing. So I'm just going to describe this and take a look at the events. And scroll right to the bottom. And you'll see over here the liveness probe failed, and the HTTP probe failed with status code 404. And the reason for that is because that endpoint doesn't actually exist inside of my application. So very soon, as much as it looks like it's running, we're going to end up with a crash loop back off, and that will affect the availability of our application. And the reason I'm pointing this out is just to show you an example of how you can easily end up in one of the pitfalls of not knowing the why behind certain best practices and actually implementing them, and instead just going with an approach where you copy and paste something that you don't know the details of. So this liveness probe is basically useless to us right now. So what I'm going to do is, we're going to make our lives much easier by actually working with a static list of updated best practices. And for that, like I mentioned earlier, I'm going to be using Datree to test the manifest. Let's start off by testing it as it is, and we'll see what Datree has to say about this particular manifest file. And so as you can see, now we've got our application in a crash loop back off. But I want to come here and I'm going to run this Datree command. And so this is basically testing against the default policy. And you'll see that there are a couple of errors which we have over here. And just so you're aware that this list could probably be a lot longer depending on the policy that you're using for Datree. And so I'm using the default policy, as I mentioned. And so there might already be some container best practices that I have implemented, such as the minimum number of replicas. So I haven't got any flags for that, but you'll take a look over here. Examples are ensuring that each container has a configured memory request. Same thing with CPU, ensuring each container image has a pinned tag. And, that's another quick win, because you don't want a situation where you're always using latest, because latest might still be used, for example, in a stage environment. But if your production environment is using latest, then you could easily end up having a new version in production that hasn't actually gone through all the relevant quality gates. And so we could go through all of these in detail, but I encourage you to actually take a look at the documentation. I love how Datree has actually detailed not only what is missing, but why you should implement it and how you can remediate it. And I'm going to open up my Datree account over here, and you can see, as I mentioned, I'm using the default policy, and you can categorize the different policy measures that you want to be making use of. And you'll see over here that I have all of these different container rules that are enabled for my default policy. And I should state that although I'm using the default policy, I have manually enabled a number of additional rules, including the container best practice rules. As a starting point, the default policy only has 21 rules enabled. If you want a similar setup to mine, be sure to enable the container rules to the relevant policy in your account, which in my case is the default policy. So what I'm going to do now is I'm going to come back to my deployment, and I've got the right manifest resource over here, or let me rather say the one that has all the remediated issues. And I will walk through this in detail step by step. Before I do that, let me go ahead and test this again with Datree. And so you'll notice over there that we had 7 rules that failed. Let's clear this and run that test again with my new manifest file. Great. And as you can see, not a single failure. So this was tested against every one of those container best practice rules in my Datree account with my particular policy. And as I mentioned, you might not be aware of why some of these are best practices. So let's go through them in detail before we actually deploy this to the cluster. So perhaps the quickest win, as I mentioned, in the container configuration for your deployments is to specify a container image tag or digest. If you don't, then this could lead to having a different version of your application being pulled each time that your container is restarted. Remember, your pods and your containers are ephemeral, so it will get pulled again. And remember that the restart policy for your container is set to always by default. So if you don't define this, you could end up breaking your application by continuously pulling and starting up the wrong versions. Now, also, you want to limit the options that a potential hacker would exploit within a container by preventing containers from sharing the host's network namespaces, because it can be used to access local network listeners and leverage to probe the host's local network. And this is not enabled by default, so that's why I've commented it out. So you can keep it that way, or in this case, or in the case where this was set to true, you can set it to false or just remove it altogether. And you also want to prevent containers from sharing the host process ID namespace. When this is enabled, it means that from a pod, someone could find all the processes running on a host, which could potentially lead to malicious executions. So you want to eliminate the attack vector in that regard as well. And in the same vein as separating container and host processes, you have to consider the inter-process communication namespace, also known as IPC. This namespace provides isolation between the host and the containers running on it. So suppose the host IPC namespace is shared with the container. In that case, it means the process within the container will have visibility of all of the inter-process communication on the host, which defeats the purpose of having isolation between the host and containers. So make sure to disable this as well. And in Kubernetes, you can manage container resources with resource requests and resource limits. So I'm going to scroll down over here so you can see my resource management configurations. And we'll start off with the resource requests. And these essentially allow you to define the amount of resources, such as CPU or memory, that you can expect a container to use. And the Kubernetes scheduler will use resource requests to avoid scheduling pods on nodes that do not have enough available resources. So containers are allowed to use more or less than the requested resources, but resource requests only affect scheduling. And then you also have resource limits, and these allow you to limit the amount of resources that your containers can use. So the container runtime is responsible for enforcing these limits and is different. And different container runtimes will actually apply this in different ways. Some container runtimes will enforce these limits by terminating the container processes that attempt to use more than the allowed amount of resources. And then last but not least, especially since we already touched on liveness probes, we come to readiness and liveness probes. And there are some additional probes as well. But this is a great feature in Kubernetes that essentially allows you to have the ability to monitor the health of your containers. So I'm going to make use of liveness and readiness probes. You saw before that I only had a liveness probe, which was essentially useless and incorrectly configured because I was making use of an HTTP request that didn't even exist. In this case, I'm going to be making use of one that does exist for my liveness probe. You'll see /test there for port 8080. And if I come to my Node.js application, you'll see over here that test does actually exist. And so there will be a response. So we shouldn't get a 404 error like we did previously. But let's talk a little bit about these. So liveness probes allow us to automatically determine whether or not a container application is in a healthy state. So by default, K8s will only consider a container to be down if the container process stops. But liveness probes allow you to customize this detection mechanism and make it more sophisticated. So it's a great way, especially for applications that are going to be receiving some form of network traffic, and you might be under the impression that your application is up and running successfully, but when a request is actually being sent there, it is failing. So be sure to make use of a good, what I would call a real life test. Like in this case, this endpoint actually exists, or you can configure the health Z endpoint like the one I had before, just to make sure it's actually encoded in your program. And then we also have readiness probes, and readiness probes are used to determine when a container is actually ready to accept requests. And when you have a service backed by multiple container endpoints, user traffic will not be sent to a particular pod until its containers have all passed the readiness checks defined by their readiness probes. So you can use readiness probes to prevent user traffic from being sent to pods that are still in the process of starting up. And in this case, I've essentially created a path, temp and healthy, and then I will then query that particular path for my readiness probe checks. So what I'm going to do now is delete the most recent deployment that I actually had. You can see it's stuck in a crash loop back off state. And I could have simply just run the apply command to modify it, but I just want a clean slate. And there you have it. You see, we've got all three replicas running, and I'm going to hit the describe command again and scroll down, and we can actually take a look at the liveness and readiness probes. And you'll see over there that we did have a couple of failures as the containers were still starting up, but we have been successful with both of them. If we were to scroll down and take a look at the different events that have taken place over here, you'll see that the liveness probe had failed at this particular point in time. The connection was refused, and even here, and that it restarted. And so it was probably after that when it worked successfully, hence us having that success over there. And so unlike before, our containers are up and running, and sure, we might still have a few restarts like this, but we've been able to remediate the main issue that we were running into before. And in addition to that, we've been able to improve the security posture of our containers. And in addition to that, we've also been able to apply some specific configurations that allow us to have better resource management for our replicas that are going to be running inside of our Kubernetes cluster.
Thanks a lot for watching. If you found that helpful, hit the like button, subscribe to the channel, and stay tuned for more.